In this video, we're going to prove the absolute convergence theorem. It says straightforward. If you come to know that the absolute value of an, the summation of that converges, then the absolute value of an also converges. And the proof is pretty straightforward. Now, before I write this, just want to point out, either a sub n equals the absolute value of a sub n, or a sub n is negative and it equals negative the absolute value of an. It equals one of those two. 7 is either equal to the absolute value of 7, or 7 is equal to negative the absolute value of 7. It turns out the first one is true. Negative 13 is either equal to the absolute value of 13, or it equals the absolute value of 13 with a minus sign in front. It's that one. It's one or the other, always. I guess it can be both. 0 is equal to the absolute value of 0. 0 is equal to negative the absolute value of 0. Both of those are true. 0 is a very odd number. Maybe one can say it's the oddest number of them all. So, for any n, we have the following. That a sub n is in between negative the absolute value of an or positive the absolute value of an. Why? Because it equals one of them. It equals one of them. The number 7 is definitely in between, I don't know, negative 7 and 7. This is true. Okay, negative 7 to 7, and you can equal the endpoints. This number is in between there. It's right there. Okay, so this is really key for this problem. Now, if you were to add a sub n in absolute values to all three sides, you would get 0 is less than or equal to a sub n plus the absolute value of a sub n, which is less than or equal to 2 times the absolute value of a sub n. Okay. Now, a quick comment. If the summation of 2 times a n converges, or let me not say if, that summation converges if and only if the summation of an converges. If and only if the summation of absolute value of an converges. Okay, this too has nothing to do with anything in terms of convergence or not. Alright. So now what we want to notice is that the following. By the direct comparison test, since all these terms are positive or 0 and they're less than a known convergent series, we have that the summation as n goes from 1 to infinity of a sub n plus the absolute value of a sub n converges. But we don't want that to converge. Well, we don't want to show that that converges. We want to show that A sub n converges. And this is where it all comes together. Note, A sub n is equal to A sub n plus the absolute value of A sub n minus the absolute value of A sub n. Basically, I added and subtracted that. So, the summation of A sub n, and then goes from 1 to infinity, is equal to the summation of A sub n plus absolute value of A sub n minus A sub n in absolute values, and then goes from 1 to infinity, and this is the summation, and then goes from 1 to infinity. I'm going to distribute their summation over subtraction. So I get this summation minus the summation of A sub n and absolute values. We've shown a moment ago that that converges. So this converges minus, and we're given that that converges, so the whole thing converges. The difference converges. That is, this converges. If the absolute value converges, then their series without the absolute values also converges. This completes the video for the proof of the famous absolute convergent theorem. Let's actually write it down correctly. Convergence. Leave a comment. Let me know how you like these videos. Leave a comment saying what video you would like me to present. Leave a comment. Don't leave any videos, please. Leave a comment showing how much or telling me how much you hate my videos. I love reading those comments. Most of all, watch and learn. See you next time.